We begin by learning the right triangle because the sine functions, the solving triangles, at this point only works with right triangles. So whenever we talk about a right triangle, you need to write this down on a piece of paper because it's going to disappear in a few seconds. Okay, but I at least want you to remember the way that we define these triangles is the angles are defined using Greek symbols. That's alpha, beta, and gamma. Alpha and beta are usually the smaller angles. It doesn't really matter. You're not bound by it. But gamma is usually the 90-degree angle, the right angle. So again, these can change, but most of the sites will keep to this. One thing though that you want to keep in mind is that your letters, okay, your Latin letters are going to be exactly opposite to your Greek angles. Okay, alpha, the one that looks like a fishy, by A. Beta, that has a tail, opposite B. And gamma, because there's really no letter C. I know there's kappa, but we don't really use that for that. We use it as a K. Anyway, so they're opposite each other. Okay, this is usually the way that you'll see it in most cases, and that's the way I'm going to stick to it. Some people might change it, but most of the time you're going to see it this way. So let me just get rid of that to keep it from getting too busy. And whenever you're going to solve one of these, remember first, of course, SOHCAHTOA. And what that's telling you is that you're going to usually, these problems are usually going to give you, remember how we divided it. We had angles and lengths, okay? So it's going to be, for example, so is opposite over hypotenuse, adjacent over hypotenuse, and TOA is opposite over adjacent. Okay, and the point here is that you're going to solve, you're going to be given two of the three things you need. You might be given only one, but here's one clue, by the way. Most of the time, you already have some information. First of all, this is a 90-degree angle. That should already give you some info. But in case you don't, the point though is whenever you're given values, it's your job to figure out which of these you need to apply. Now, what we're going to do to make some of our solutions easy is we're going to build a table of the sine, cosine, of the sines, the cosines, and the tangents. I'm going to go pretty quick, but I'm going to give you a little bit of information ahead of time, which is going to help us to build a table. Now, what I've given you are three fundamental triangles. You're going to see these everywhere, and we're going to build our table with this information. So what you're looking at here is, of course, 30, 60, 90 triangle and the 45, 45, 90 triangles. And we're going to treat the hypotenuse as the radius all the time. Okay. Now, if we do that, if the radius equals 1 and the angles are these, then this side is going to be 1/2. This side is going to be the root of 3 over 2. Okay. In the case of the 45, 45 triangle, well, you should know this is going to be the radius of 1, and each one of these is going to be root of 2 over 2. Okay. You can solve them later, but for now, just take my word for it. Now, what we're going to do is we're going to go ahead and solve each one of these once again. So let's start. The radian measurement, remember that that's 180 over pi to convert. Okay, so 30 degrees, if you do it, you'll notice that it's pi over 6. 45 degrees equals pi over 4. 60 degrees equals 2 pi over 6, which is just pi over 3. 90 degrees equals pi over 2, and 180 degrees equals pi to 70 degrees, and all the other multiples within. So there's more, but I'm just going to hurry up. That's 3 pi over 2, and 360 degrees is 2 pi, or 0. So the sign of 0, we already said, is 0 over 1. Now notice this makes all of our calculations easy, because when we're calculating here the hypotenuse is always 1. So sine of 0 is 0. Sine of, we're going to go as small as we can, so sine of pi over 6. Okay. And that's going to be 1/2 over 1, so it's just 1/2. Look over there. This is opposite over hypotenuse, so that's why that's 1/2. Okay. The sine of pi over 4, well, that's this one, 45 degrees, pi over 4, and the sign here is root of 2 over 2 over 1. Oops. Let's get rid of that circle. Root of 2 over 2 over 1 is just the root of 2 over 2. Okay, the sine of pi over 3. Well, that's the sine of pi over 3 is this guy here. And that's root of 3 over 2 over 1. So that just becomes the square root of 3. And by the way, notice, only the root of 3 is under the square root. The number 2 is left alone. It's not square rooted, so don't make that mistake. So now, just like I said, to give you an idea, this should be about 707, and this should be about 0.867. Okay, and then the sine of pi over 4, or I'm sorry, pi over 2, which is 90 degrees. Now, that one's going to be, notice, we've got 90 degrees would be right here, right? So that would be opposite over hypotenuse, 1 over 1. That equals 1. Okay, and what's next? And next is the sine of pi over 3, okay, and then we're going to have now notice, many of these I just reduced them, so this is actually 2 pi over 6. So if you want 1 pi over 6, 2, 3 pi over 6, 4 pi over 6, 5 pi, 6 pi over 6, 7, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and then this would be 12 pi over 6. I just reduced them so that it wouldn't, because you really want to work with the reduced values, not the crazy values. So now we're going to continue with our sine function. Okay. So let me show you how I'm getting some of these values. You might be like, oh, how's he doing that? Remember, sine of 4 pi over 3 is a triangle that, according to this, is doing this. Okay, it's going like that. Okay. That's the angle that it's got. But what triangle does it make? Well, it makes a triangle like this. Right? Remember, this is the hypotenuse. The angle is right here. So if this is the angle, then this is the opposite. This is the hypotenuse. And this here is the adjacent. Okay, and in this case, okay, our radius is still 1. It's always 1, so we don't worry about that. All we worry about is the opposite. Well, what's the value of the opposite? It's going to be down here. This value is going to be the root of 3 over 2. And if you don't get it, look at this triangle here. Pause the video and look at what's going on. Just turn this triangle so that it looks like that. And you will see that this y value is the negative root of 3 over 2. So if we do that, then this value must be the negative root of 3 over 2. Okay. For the same reason, this is going to be 0. Let's do it one more time, just so you'll see. Okay. First, we'll do these just kind of easy. So let's look at this again. We're drawing the angle from here all the way to 30 degrees before the full turn. And so our line is going to run like this. Now wherever the line is, this is always length 1. Okay? Oops, let me make it better. There we go. And so this is a third, and remember these are all 30, 60, 90 triangles because this angle in here is 30 degrees or pi over 6. That's why 11 pi over 6 plus 1 pi over 6 will make it 12 pi over 6. So this is pi over 6 right here. Okay. And this will be 2 pi over 6. Okay. 30, 60, 90. Okay. And if we look at this triangle here, this pi over 6 means that this is 1/2 right here. Right? So here's 1/2. Negative 1/2. Remember? But on the x value here, this is going to be root of 3 over 2. Okay? So what's our value? Well, for this value here, okay, for this, we built this triangle. And so the opposite of this theta here, and you might be like, well, it's pi over 6. They're the same thing. Okay? So in theory, this is really negative pi over 6. The way we're really doing it is like this. This pi over 6 is really going like this. You can do it either way, by the way. It works perfectly. Okay? So that is, once again, the length is 1. So what is the opposite? Is 1/2 over 1. Oh, but it's negative 1/2, remember? So it's just negative 1/2. Do a few of these. Do a few the long way first. Okay, don't just trust me, because I know, especially if this is new to you, it's just, it's going to seem crazy. But once again, this one, if it's sine of 2 pi, it's just perfectly flat. Okay? In this case, what's the opposite? The opposite is 0. 0 over 1 just equals 0. And then we start all over. Okay? Let's now try it with the cosine. So now we begin with the cosines. Okay, so let's remember what it means. So the cosine of 0 is the same as saying over hypotenuse. And since our unit circle is always 1, we ignore it. It's just the adjacent, whatever the adjacent is. Okay. And when the angle is 0, what is the adjacent? The adjacent is right here. And the adjacent equals the radius, which just means 1. Okay. The cosine of pi over 6. That's easy. It's right here. To solve the cosine of pi over 6, first we set up a triangle with the angle being pi over 6 radians. That's going to give us an adjacent of the root of 3 over 2, and of course the hypotenuse is always 1. Now the same thing is going to go for pi over 4. Now to solve for the cosine of pi over 2, we draw our angle here really close to pi over 2, so really close, probably about here. And we notice that the adjacent is almost 0 and the opposite is almost 1. So the adjacent being 0, we get 0. Now for the cosine of 2 pi over 3, similarly, we draw an angle here about 30 degrees out. We draw up our line, and we have a negative of 1/2 and the root of 3 over 2. And so that gives us an adjacent of negative 1/2. And so the cosine of 3 pi over 4, similarly, is negative root of 2 over 2. Cosine of 5 pi over 6 is the negative root of 3 over 2. And the cosine of pi is, of course, then negative 1. Now, if you want to see why, we do the 180, and our line is out here, and we notice that the adjacent is 1. Okay, so we say cosine of 7 pi over 6. We drop this here. We notice that this is negative root of 3 over 2. The opposite is, of course, negative 1/2, but we don't use that. We just use the adjacent. And for the cosine of 5 pi over 4, we similarly have negative root of 2 over 2. Cosine of 4 pi over 3 is negative 1/2. And, of course, cosine of 3 pi over 2 is 0. Cosine of 5 pi over 3, let's finish these off, and then we'll draw these. Now for the cosine of 5 pi over 3, we draw this all the way till we hit about the 60 degree or 30 degree mark, however you want to look at it. We raise our line here. That's 60 degrees. And that's 30. Okay, so that's 1/2. And that's root of 3 over 2. Okay, so we've got an adjacent of 1/2. We don't use the opposite, of course. Okay, cosine of 7 pi over 4 is similarly. Now, for the cosine of 11 pi over 6, we do something similar. We write the 30 degree angle here. And that's going to give us a root of 3 over 2 and a negative 1/2. We only use the root of 3 over 2. And finally, cosine of 2 pi is 1. Moving on to the tan, we have opposite over adjacent and the tangent of 0. If you look at this, you're going to notice that an angle of 0 gives us an opposite of 0 and an adjacent of 1. So we got 0. The tangent of pi over 6. This one's going to be interesting, so let's go ahead and draw this out. We've got our angle here, got pi over 6, and our opposite is 1/2, and our adjacent is root of 3 over 2. So if we put them into a fraction, 1/2 root of 3 over 2, we solve, we've got 1 over the root of 3. Now, if we rationalize the denominator, we get root of 3 over 3. Now remember, rationalizing, you do it by multiplying it by the number that is, this is the same as 1. And so that's how we get our rationalized answer. Now, tangent of pi over 4. Well, that one, if you've got root of 2 over 2 and root of 2 over 2, both on the adjacent and the opposite, you get 1. Okay, now the tangent of pi over 3, let's go ahead and look at that one once again. Here we go, that's pi over 3, and this is root of 3 over 2, and this is 1/2. So if we put them into a fraction, we cancel out the 2's, we get root of 3. Okay, now the tangent of pi over 2, now this one's interesting. Okay, so we draw out our line here, 90 degrees, and we're going to notice that our adjacent is going to be 0. And 1 over 0 is undefined, so we can't do that. Now the tangent of 2 pi over 3 is going to be, here we go, up 30 degrees, and then we drop this root of 3 over 2 and 1/2. Negative 1/2, of course, so that's going to give us negative root of 3, and tan of 3 pi over 4. By similar logic is negative 1. The tangent of 5 pi over 6, similarly, is going to be negative root of 3 over 3. And the tangent of pi, 180, is going to be 0, for the same reason tangent of 0 is 0. Tangent of 7 pi over 6 is root of 3 over 2. Let me show you. There we go. Okay, so that's negative 1/2, and that's negative root of 3 over 2. So we put them on a fraction. They both cancel the negatives, but we still get the negative root of 3 over 3. Tangent 5 pi over 4, like all 45-degree tangents, is 1. And the tangent of 4 pi over 3 is negative root of 3. If you notice, good. Okay, now we have negative 1/2 and negative root of 3 over 2. So that's where we get that from. Now, the tangent of 3 pi over 2, this one's interesting. And in this case, once again, we have the same problem, which is that our opposite equals our hypotenuse, which equals negative 1 over 1. Doesn't really matter because the adjacent, once again, is 0. So 1 over 0, which is undefined. Okay, let's continue. So now we look at the tangent of 5 pi over 3, and once again, we draw a triangle here, and we've got negative root of 3 over 2 and 1/2. So that's going to give us negative root of 3 once we cancel the 2's. And tangent of 7 pi over 4 is negative 1. Tangent of 11 pi over 6, once again we draw this here, 30 degrees, root of 3 over 2, negative 1/2, so that's going to give us negative root of 3 over 3. And finally, tangent of 2 pi is 0. I said 0 because it's the same thing. So we're going to conclude this video at this point with the solutions to the sine, cosine, and tangent for basic angles. And next, we're going to move on to solving some triangles using these. So before you go on to the next video, write down a little table with sine, cosine, and tangent, and the solutions, kind of like this. But don't cheat. Write your own. And I'll meet you at the next video. Okay, take care.